Okay, this is experiment number 9, or op-amp experiment number 6. This is called gain bandwidth product, and it shows a interesting phenomena of all amplifiers. Matter of fact, you might extend this principle to human life. It turns out that there are some sayings like a jack of all trades, a master of none, and that kind of indicates that if you know a lot about a lot of different things, you're not an expert about anything in particular. And then there's a lot of research done about people who might have a PhD in a particular subject, but they're so focused on that subject they don't know much about anything else around that subject. So here we are with Circuit Maker. I'm going to open up the first circuit. So let's see what we have. And let's make this bigger. Maybe we'll go with 150 for the scale factor. And move this around a little bit. Here we go. So what you see here is a circuit. Is again standard 741 op-amp. It has a input sine wave of 100 millivolts peak to peak. Got an RF of 100K and an RN of 1K, which would indicate we should have a gain somewhere around 100. Actually, since we're going into the plus or non-inverting input, the gain should be 101. So let's run this. And when we run it, two things come up. An oscilloscope trace. Let's make that a large signal. The input is the green one and the output's the yellow one. I've done screenshots of this that do the measurements. You can see that obviously the yellow output is much bigger than the input, and it's even hard to see the input wiggling. If I was to take and go to manual here, I could take and play with the, get rid of this guy, play with some of the controls. If I go the right way, you'll see the yellow one goes off screen, but here now you can see the input of the 50 millivolts plus and 50 millivolts minus, 50 to 50 or 100 millivolts peak to peak. Let's go back to automatic. And again, now you see the very large output with a smaller input. If I take and diminish this guy in size, let's try to, and then go over to this guy, this is the Bode plot. And the Bode plot shows the output versus frequency. Now, on the left-hand side, the output is at the top of the scale. The yellow signal says 40, it's 40 dB. Okay, and it turns out that you notice as you get farther over to the right that the output starts to go down. And in the screenshots I've taken and measured the bandwidth of this. That is where the signal goes down to minus 3 dB below the 40 dB, or the output at 37 dB. And if I take quickly and run the cursor A over here, it turns out, and I'll put C up top, if I take a look at C, and I go to C is about 37, somewhere around there, I see that A and C kind of line up at that point, and that's about 10 kilohertz. So the gain is 40 dB, or since voltage gain is 20 times the log of the voltage gain, it turns out that 40 dB is a factor of 100 or close to it. So it turns out 100 times 10 kilohertz gives me about a gain bandwidth product of 100 times 10K, or 1 million. Okay, let's get rid of this guy. So that's the first circuit, called gain bandwidth product circuit number 1. Okay, let's take and stop that. Let's take and open up gain bandwidth product number 2. So here's circuit number 2. Open that guy. We won't save anything. And I probably won't blow this up. It's probably visible. Well, let's blow it up. So we'll go to 150 again. And there's now a circuit where the input now is only 10 millivolts peak to peak, plus 5 to minus 5 millivolts. The reason for that being is that the gain of this circuit is very large. It's 100K over 100, RF over RN plus 1, so it should be gain close to 1,000. And we'll run this circuit, and we can see the output. I'll blow this guy up. I'll get rid of this guy over here, blow this guy up, and you see that the input hardly changes at all, but the output now goes from about plus 5 volts down to minus 5 volts, or a gain over, 1,000. 1,000 plus 1 plus, or 1,000 plus 1 or 1,000 are very similar gains. If I go and drop this down and I look at the Bode plot, now I see that the gain is about 60 dB, which is a factor of 1,000, and I go down about 3 dB from that to about 57 if I can, somewhere around there. Oh, they're touchy, somewhere around there, and I move my cursor A over. I'll discover that happens at about 1 kilohertz. That shouldn't surprise me. 1 kilohertz times 1,000 gives me a gain bandwidth product of 1 million again. Okay, I'll stop that guy, and we'll take and load the third circuit here. And I'll blow this guy up again like all the rest of them. And there we are. Now this one, you might notice I've taken and changed the input back to, now in this case it's 200 millivolts peak to peak, because it turns out that we have a gain now of 100K over 10K, which is about 10. And let's run this. And it turns out that actually the gain would be 100K over, oh, where did we go? Run it again. We have the output here, which now we can actually see. Our gain is, output's about plus 1.1 volts to minus 1.1 volts, or about 2.2 volts, where the input is a couple hundred millivolts. So that's a gain of about 11, which we expect, RF over RN plus 1. If we take a look at, I'll have to play some games here. I don't see the Bode plot, so I'll go up to Window and click here. Now it brings the Bode plot back. So now we take and look at the Bode plot. Now you notice that the gain is a little bit over 20, looks like it's about 21 dB. And if I go down from there about 3 dB, a little more tricky now. If I go down about 3 dB, somewhere around here, and I bring cursor A over, it turns out that that's the cutoff frequency right around there. And again, I'm not surprised, because what do I see? I see a bandwidth now of 100K and a gain of a little bit over 20 dB, which is a factor of 10. So I multiply those out and I get a gain bandwidth product of, again, 1 million. So no matter what my gain is, the bandwidth changes to make the gain bandwidth product equal to about 1 million. 1 million or 1 megahertz is the cutoff frequency of a 741 op amp, so I'm kind of happy with those results. My last portion of the experiment, I ask you to calculate. So I'm going to take and open this guy. On my screenshots I show you this. It turns out you might notice that there's no value of Rn given. You're supposed to calculate it. And I run this, and what you'll do is you'll see this as a screenshot, which you should confirm that the gain is 40, as was asked. And then what you have is this guy here, which is the Bodie plot, and I've done screenshots to show you what the new bandwidth is. You should multiply the bandwidth times the gain, and hopefully it's going to come out about 1 million again. So it doesn't matter if it's an op amp or a transistor. Turns out in any case, if you increase the bandwidth, the gain has to go down, or if you increase the gain, the bandwidth has to go down. You get a constant, what's called gain bandwidth product for any type of amplifier. So that's it for this experiment.